Hi, for some of you who may not know me, I am Olivia Crawford, and this afternoon I am here to conduct a short presentation on numeracy across the learning areas. I thank you for giving up your time this afternoon to come along to my 20-minute speech to cover the importance of the general capabilities in the Australian curriculum and how to link numeracy with another KLA. However, I assure you that I won't be talking the whole time. I've tried to make it as engaging and informative as I could for you all. What are the general capabilities? In the Australian curriculum, the general capabilities are the knowledge, skills, behaviour and dispositions that students need to develop confidently and effectively and apply them across all subject areas. What do the general capabilities do? The general capabilities help students become a successful learner, confident and creative individual, and active and informed citizen in everyday life. As seen in this figure on the screen behind me, this is a photo of the 7 capabilities from the Australian Curriculum website, and we focus on the intercultural understanding, ethical understanding, personal and social capability, critical and creative thinking, ICT capability, literacy, and finally numeracy, which today we are just focusing on the numeracy content descriptor and how we as teachers can support numeracy in a different learning area. So what does numeracy help our students with? It helps students become numerate by developing knowledge and skills of mathematics across different learning areas. This involves the students being able to recognise and understand the role of mathematics in the classroom along with the world around them, and it enables them to apply their numeracy skills purposely in life. For example, when they go to the shops, they can work something out, like a price, they can work out how much they're going to save. Can you please raise or nod your head if you've ever seen this image or a few of these words before? Right. That's about 70% of you. That's good. So since we are focusing on numeracy, the image behind me is what the general capabilities of numeracy are. There are 6 organising elements of numeracy, which are often referred to as 6 key ideas as well. They're different on the same website. On the website, there are tabs that go into further detail of what the key ideas are. However, we will be further discussing these key ideas by linking it to another learning area, which I have chosen for us. So what can we do to allow our students to have the best opportunity to use maths in all of our different subjects now? Literacy, science, art, drama, PE, Kiwi. What can we do? With that question that I just posed flying around in your head, I'm going to give you 2 minutes of thinking time. Maybe brainstorm, draw with the pencil and paper that I've provided for you. Draw some thoughts, discuss it with the person next to you, and then we'll come back and we'll discuss some questions about how we can combine math with another subject. Alright, that's thinking time up. 2 minutes has been and gone. Do we have any thoughts? Yes? Would we like to share? Yep. Well, myself and Mr. Jones came up with make the activity fun and engaging and only bring little amounts of maths into the activity. For example, if you're working on PE, work on PE and don't overpower the activity with maths, but still use elements of maths in there. For example, did I beat my record from my last run to this run when I was doing a 50-meter sprint? Can I work on my timing? And that kind of. I loved all of your answers to the question that I posed in the slide before, and this is my answer to that question. And I said, we as teachers need to provide students with opportunities to transfer their mathematical knowledge with context outside of the mathematics classroom. And we will be exploring this idea through another learning area that I've chosen, which is science. I have another activity planned for us, and the time for this activity, we have 7 minutes to complete it, which is very, very possible because we all know how to read and write. This paragraph that is behind me, yes, I know it looks very, very big, but it is numeracy within the science general capabilities, and I got it from the PDF document or the Word document that is on the Australian Curriculum website. And on the table in front of you, I've all printed out a copy, and there's a highlighter there for you. And I would like you to read through this paragraph carefully and highlight the numeracy demands that you come across in this paragraph. Here's that same paragraph that I highlighted, and this is what I thought the numeracy demands were that I came across in the paragraph. Yours may look like mine or a little bit similar. That's okay. The next part of this activity is using the table that I have provided that's also on your table. It might be face down, just turn that over, and it's a table with a column with the 6 key ideas or the organising elements of numeracy, and I would like you to put the pieces of words that you highlighted in that science paragraph into the appropriate columns that you feel is appropriate and where you think they go. Now go ahead and do that and let me know when you are finished. This is how I interpreted the paragraph about science and what I've read and the parts that are highlighted, and this is where I put them in underneath the subheading. Yours may be similar, and hopefully it is. You may take those papers home and keep them for use and for a later reference when you need them. The next part of the activity that I want you to do is to work for us all to work collaboratively together and identify what ideas are strongly evident and what ideas are less evident when looking at science. So yes, considering issues of uncertainty and reliability in measurement, that is strongly evident. Collecting qualitative and quantitative data, strongly evident. How about over that side of the room? Yes, data analysis skills and how to identify terms and patterns. Yes, strongly evident. And the other side of the room? Yes, the statistical analysis of data, including issues relating to accuracy and validity. Yep, and mathematical relationships to calculate and predict value. So that means we have 2 left, and what do you think they are? Less evident? Yes. Using informal units, Then formal units, that's a bit less evident, and the use of mathematical tools to provide evidence to support a hypothesis. Thank you. The next couple of slides is I have chosen two specific content descriptions from the science syllabus, and I talk about the year level, the strand, and the substrand. And then we talk about how these require students to use their mathematics knowledge and skills and different strategies. And I also show you how to use the content description for science and line it up with the key ideas and the mathematics content descriptions. This is for a year 2, and the strand is skills and the substrand is working scientifically. And the content descriptor is we investigate questions and predict by collecting and recording data, sharing and reflecting on their experiences, and comparing what they know and others know. And to link this with the key ideas, it is the data analysis skills, identifying and interpreting trends and patterns, and collect qualitative and quantitative data. So measurement and recognizing and using patterns and relationships are the key ideas. A little activity that I designed that you feel free to go back to your classroom, differentiate it for your students, but it's called What Sinks, What Floats. And it is a hand-on experience where students work in teams to find out what objects sink and float. It explores the push and pull effects and how an object changes in the water. The learning outcomes is science and math, and students will make observations to whether objects will sink and float, and they will record their findings in a list, a column graph, whatever they please. I do have a table for them. Identify ways to change an object that floats into one that sinks. So for example, they might have a balloon that floats. Before they blow the balloon up, they might put a few rocks in it, and then not blow it up as much and just let it sink to the bottom. And then use a table to record predictions and observations, and draw pictures to record their findings. For this activity, you'll need paper towels so the students can dry their hands so their book doesn't get wet, their science notebook, objects that float, so the duck, and objects that sink, rocks, paper clips, things like that, plasticine. And I want them to observe how the plasticine changes shape when it hits the water, and the table that I have made for them to fill out. The worksheet is self-explanatory. I got it off Kahootl, and you just write the object that you have, you predict whether it will sink or float, the students observe what happens, and they'll circle whether it does sink or float, and they'll explain why. And to add a little bit more maths, if they're finding this really, really easy, they can get a stopwatch out and see how long does it float before it sinks, and they can time it like that and see the differences in objects and feel the weight difference. They can even weigh it if they would like. The second activity focuses on year 4, and again the strand is skills and the substrand is working scientifically. The content descriptor is investigate their questions and predictions by analysing collected data, suggested explanations for their findings, and communicating and reflecting on the processes undertaken. The key ideas that link with this descriptor is using measurements, so they consider issues of uncertainty and reliability in measurement, interpreting statistical information, So they'll use mathematical tools to provide evidence and in support of your prediction, and recognizing and using patterns in relationships, data analysis skills. This lesson is all about how to keep my tea warmest the longest. So as a teacher, I've posed a problem to the students asking them, how can I keep my tea warm for the longest period of time so I stop drinking the tea cold? Because as a teacher, you get very busy, sidetracked, and your tea just goes so cold. We all have that problem. Then get students to suggest ways to keep it warm. They'll give suggestions like put it in a warm place, put it near the heater, use newspaper, foil, put it in a thermos container, cup. And then obviously, because we're dealing with hot objects, we need to talk about safety procedures, the do's and don'ts, like don't stick your hand in it. If you feel it's hot, use a glove. If you feel it's too hot or you don't feel comfortable, ask the teacher, because we are dealing with hot things. Next, get the students to measure with the thermometer at the beginning, once you pour the tea in, how hot it is to start with. Then get them to predict how cold it will get. And then after 30-45 minutes, re-measure with the thermometer how much colder, how hot it still is, and was it close to their predictions. And then once they've done that, students go back to their table, and then they will use their results to form from the table to form a column graph, and they'll have the results that it started with and then the results it finished with, and by that they can visually see which one kept it the warmest and which one decreased the most. This is just the worksheet for when they measure with the thermometer, so they've got the different suggestions that the students came up with. And then for measurement 1, guess how much colder it will be in 40-35 minutes. Measurement 2, and how much was they off by. So this makes them use subtraction or addition. And then they go back and they use all that information to draw their column. Thank you for your time this afternoon. Much appreciated. I hope you learned a lot on how to combine math into another KLA and found it very interesting. If you have any questions, feel free to come up to me after this meeting, or just come up to me in the playground and I'll be happy to answer them. Thank you.